Hi, so in this video, we are going to talk about criminal machine learning. Very hot topic. Very topical, very interesting, very controversial topic. Once again, this is heavily borrows from Calling BS, the excellent book. You should check it out. Bergstrom and West. I'm modeled a lot of this talk on what they say in their video and in their case study on their website. About criminal machine learning. Okay, so there's a few different examples of criminal machine learning. This is a very popular, it's been a very popular topic over the past 10, 15 years. There are machine learning algorithms that get used to predict where crimes are going to occur, and then to send police out to respond. So predpol is one, a very famous one that gets used in California. You can see there's a mathematized criminal behavior model that gets used here. And this is kind of based on earthquakes and things like this, that predicts purports to predict where a crime is going to occur. And then it actually creates these sorts of hotspots or these regions where crimes are predicted to occur based on previous data and based on previous patterns where crimes have occurred in the past. The police actually send cars out there and claim to solve crimes and stop crimes because of it. So this has been around for 10, 15 years. It's used. This is data directly from the predpol website. This is a product that gets used by the police. This is stuff that's actually been around for a very long time. So one of the first algorithms for so-called predictive policing is called the police beat algorithm. And it comes from this operations researcher called Saul Gass in the 1960s. I read about this in this excellent book, You Are Not Expected to Understand This, which you should check out as well. And this police beat algorithm was designed to do a few different things: pattern recognition, profiling, so-called dragnetting, so linking suspects of a crime with past crimes, and patrol positioning. So this was positioning police patrols based on where most crimes have took place. So that's sort of the input data, and where known criminal suspect profiles predicted who will most likely commit those crimes and where. So an algorithm that's based on historical crime data to predict who was going to predict crimes and where. So that was taking in data from demographics and things like this. You can imagine how this can go horribly wrong, and it does. So here's a picture of the mathematical algorithm. It's a piece of operations research, a field of mathematical optimization. So there's an optimization algorithm that's being done there. You can think about the issues with this straight off the bat. I think you have to really interrogate what is the data that's going into these algorithms. It's difficult to know what that is, and what are the outputs, and are those algorithms more likely or not to be biased against different demographics, different groups of people. So it's a case of garbage in, garbage out a lot of the time with these algorithms. Here's the case study that I want to focus on for this video. This is a paper that came out a few years ago called Automated Inference on Criminality Using Face Images. So this was an amazing piece of machine learning purported to be able to take pictures of people's faces and then detect whether they're criminals just by running a neural network, deep learning algorithm on those images. So you can tell just from people's faces whether they're a criminal or not. This is an extremely old idea, going back hundreds of years, back to a field called craniometry, which basically says, and phrenology almost, where you can look at patterns in people's skulls and things like this and detect whether they're criminals or not. And this is junk science from a long time ago. So anyway, let's talk about the training data in this automated detection of criminality paper. So here's their training data. So here's 3 samples of photos of criminals. So these are known criminals, so people who have been charged of crimes. So there's one photo set, and there's lots and lots of images in this set. And then here's a set of samples of photos of people who are not criminals. So they're in the non-criminal set. And then, okay, so that's the training data, right? So they're the inputs to the algorithm. And then, you go and train your CNN, your convolutional neural network classifier. Here's a few different classification models. You can look at these accuracy results, and they're numbers that are big, they're close to 1. You can look at the false alarm rate, and they're small numbers, they're close to 0, so that's good. You can look at these things called ROC curves, receiver operating characteristic curves, and they're very close to being up in the top left of the picture, which is what you want to see. And you can get the area under that curve, which should be close to 1, and these ones all are. And so cool, that looks like it's all working. We can, there's some fancy statistics that we can point at there. Great. So that model works by the metrics that they said, that they set. And you can even, they even talk in the paper, interrogating this a bit further. Like, here's an actual picture of the trained model. Here are the features for these so-called discriminative features, which tell you whether a face is a criminal or not. So these are the parameters that are important: the distance between the eyes there, this angle in the nose, and then this angle, this curvature row of the face at that point. They're the things that you know, and it tells you whether somebody's a criminal or not. At this point again, I'll say pause the video, have a little bit of a think, think about whether you believe this or not, and then we'll come back. So pause the video. Okay, and then come back. So let's think, do we believe this? What's going on here? Like, do we believe that these angles here actually discriminate criminals from non-criminals? What's the story here? What do you notice about this row parameter here? It's frowning. This angle, this curvature of the face is telling us whether these faces are frowning or not, right? So we can even interrogate this further by looking at the outputs of the model. So here, these pictures are telling us what the average faces are. So what the model outputs for the average criminal and non-criminal faces. So criminals on the left here, right? The average criminal face and the average non-criminal face. What do you notice? The ones on the left are frowning, the ones on the right are smiling. And of course they are. The photos of non-criminals are taken from, just corporate websites, things like this. The photos on the left are not mugshots, but they're photos of known criminals, right, who have been convicted of a crime. So of course they're frowning. So this is a real case of, if you think about garbage in, garbage out, if the training data is biased, the output is going to be biased as well. And it's there, right? These are the figures directly from the paper. There's a caveat to this, of course. This was a highly controversial paper, and the authors responded to it. They actually make some good arguments defending their work, but they say here in the section on smiley faces, they say they tried to control for facial expressions, smile versus sad, but they didn't control for micro expressions, so relaxed versus strained photos. And then they intend to, they basically admit that they need to do tighter controls on that, do better statistics in future versions of this. They show some images here on the right. This is in the response paper of faces that are criminals and non-criminals. I don't know about you, these faces at the bottom look like they're smiling a bit more than the ones that they up the top. So, I think there's a lot of work to be done, and I think we can call this article, as many other people have before, BS. And as you can't detect whether somebody's a criminal from just from their face. So what's the point of all this? This criminal machine learning here is actually another instance of garbage in, garbage out. So to be able to be skeptical about these grand claims that get made in these research articles, think about what's the training data, what's the output, do they make sense? And if there's garbage in, there's likely to be garbage out as well, and that's the theme of these videos.